Hello, students. Welcome back to another session on a topic of physics, that is gravitation. Okay, so let's start with universal law of gravitation, what it talks about, what does it say, and how does it become universal over time. Okay, so yeah. So first of all, gravity was introduced to us by Newton, that we know, right? Sir Isaac Newton in around 1687, he, has come up with the idea of gravity. When an apple fell on his, head, you can say, or on his body, he realized that, an insight came to him that why, which is, going up like a falling, it's not going up, it's going down. Why so? Why it's coming back on earth? Okay, so then after that, the idea of universal law of gravitation came into picture. Okay, so what does it talks about? It says that any or every particle, okay, let me just change the pen color once. Yeah, so every particle in the universe, actually, whatever it is, like I am sitting near, this wall, or maybe, this, let's say this small box is here in my hand. So every particle present on this planet, okay, it is, or not on this planet only, on any planet, if it is there, okay, or in whole universe, if we talk about, everything or every particle is attracting each other with some sort of force. Now, how much that force will be? So it will be directly proportional to the product of their masses. For example, I have certain mass, and maybe my some family member, let's say brother, is sitting next to me. Okay, so we both have this like power of attraction. Okay, and what it does, our both of the masses, if we product them, okay, if we multiply them, both masses of both the person, okay, and then if we divide it by the square of the distance between them. Okay, so let's say if the distance is 10 meters here, so it will become 100, right? So the square of the meter, that much force with which, a particle is attracting each other, or two particles are attracting each other. Okay, if I'm sitting and that bottle, one bottle is just beside me, you can say, or in front of me. So we both are applying some sort of, force, that is gravitational force, towards each other and pulling each other, towards each other. So what kind of force will be there? That will be gravitational force. Okay, and it depends on the mass and the distance between them. It is directly proportional to the mass. So that means if more mass is there, okay, of any of the particle, you can say, so what happens? There will be more force. Okay, but if more distance is there, then the force will be less. The attraction will be less. Okay, so here the formula for this universal law of gravitation is F is equals to G M1 M2. That means here multiply is there, okay, in between M1 and M2 upon R square. Okay, or you can simply just write it like this as well. Okay, like this also. You can write it like, let's say, this as well. Okay, so you'll be able to understand. Now, what exactly force here is? It is gravitational force. So to calculate among two particles how much gravitational force is there, you firstly have to know the masses of both the particles and also the distance between their centers. So that means if this is particle A and this is particle B, and we have to calculate the force between them, we must know their masses, let's say M1 and M2. And also we must know the distance between the centers. Okay, this is not the accurate center. Let's somewhere here maybe, okay, and here. So this distance also you must know. Okay, and then you have to square it. So then only you'll be able to figure out the gravitational force present in between these two particles. Now, here G is there. G is universal gravitational constant. Okay, that is pre-decided. So what is the value of G? If G is a constant, that means it does have a certain value. You might have studied in your previous, uh, classes of physics, or maybe mathematics, a constant and a variable. Okay, so constant is something which does not change. So the value of the gravitational the this constant universal gravitational constant would be same. Okay, now let me just move ahead. Okay, so universal gravitational constant, actually the value of it would be around 6.67 into 10 to the power minus 11. Okay, Newton meter per square per kg. Okay, per kg square. So this is the value of G. This is the standard value which will be used in all the calculations. Okay. And if we talk about in which year, so again, 1687, Newton actually published this work of his. And okay, in 1798, Henry Candish was the one who actually first measured the value of the constant. Okay, so G is a universal constant. I have told you that determines the strength of gravitational attraction everywhere in this universe, wherever you want to calculate. And it's incredibly small. If you can see here, the value is in minus 11. That means it's very, very, very tiny. Okay, so that's why we will only notice gravity between very massive objects and not in the small objects. So this G constant is such, so small that even though if you multiply it by the masses, we are not getting enough, big value, big force value, gravitational force. So that gravitational force is not visible among different small particles which we see around every day. But if the masses are very huge, very big, for like example, like if we're talking about a star or a planet, right, then we are able to see that how this gravity is working. Okay, and how and why Earth is revolving around the sun, right, and moon is revolving around the Earth. So all these things actually become self-explanatory if you get the concept of gravitation. Okay, so now gravitational law, what are the features? First is, I have told you that it is directly proportional to the masses. That means the more heavier the bodies will be, so the gravitational force will be stronger or more. Okay, so double the mass, double the force. Okay, so if somebody asks you that if we are doubling the mass, okay, mass is twice. Okay, so how much force will be there? You will say that force will also be twice. Okay, 2 into, you can write like this. Okay, so for example, Jupiter exerts a stronger gravitational pull than Earth because it has more mass. Okay, now, sorry. Yeah, if we talk about in the second, feature would be inversely proportional to distance square. Okay, so double the distance, force becomes 1/4 of the original force. Why so? Because the distance, if you remember, is in square, and also under, it is in denominator. Okay, so what happens? The force is inversely proportional to the distance, the square of the distance, and that's why the force will become 1/4. Okay, it will become 1/4 if you will double the distance. So if you increase the distance, attraction decreases, but if you increase the mass, attraction increases. So this you have to remember. Sometimes they will ask you question indirectly in this format only. So these 2 points, if you can remember, you will be able to solve a lot of questions and get marks in this chapter, because this is the tricky part here. Okay, now mutual force. So both the objects attract each other equally. With equal force it is attracting, like I told you, but it is very minimal. The force is very minimal because I told you the masses are very, very small compared to a planet or a star, right? So you pull on Earth with exactly the same force the Earth pulls on you. So this is related to Newton's third law as well, that every action has equal and opposite reaction. So that is happening here. And because of that, sorry, it's there. Now, universal application. It applies everywhere in the universe, from, falling, apples falling to galaxies forming, everything. Okay, so a lot of questions of this universe can be, proven or solved, or, yeah, the problems could be solved by just knowing about gravitation, and you are already learning a lot here. Okay, so now let's try to do one problem of gravitational force. So here you have to find the gravitational force. Don't try to look at this. I mean, you can, but don't take a peek. Try yourself first. So the first object is having a mass of 10 kgs, right? And the second object is having the mass of 20 kg. And the you can say the distance here is 5 meters. Right, now you know the formula, and you also know the constant, the value of the constant as well. So you will put the value of the constant and as well as the value of masses and the distance in the formula, and you will get your answer. So the gravitational constant, if you remember, it is 6.67 into 10 to the power minus 11. Now you will put the next mass. So mass 1 is how much? 10 into another mass is 20, right? And the value of the distance is 5 meters, right? So, but it is in square. The formula is in square. So you will put the square, and then when you will solve it here, this will remain, let's say, same. Okay. You can write the complete thing. Okay, let me just write so that you don't do mistake. You'll say that I have written like this, and you will also do the same thing. Okay. Don't take shortcuts. Okay. So now this is the value 200 upon 25. Now this, if you will solve, try calculating it by yourself, you will reach to a value of 5.34 into 10 to the power minus 10 Newton. Okay. So this is the gravitational force. Now here the force is extremely small because the masses are very, very small, very tiny. Okay. Compared to a planetary body. That means any planet, if you will pick, from that, the masses here are very, very small. Okay. Right. So moving ahead. So applications of universal, gravitation. So one second. Let me just pick the pen. Yeah. So it is used in planetary motions. We have discussed that, right? How everything, do not fly off. So for example, why Earth does not, fly away from sun, and why it revolves around sun. Satellite orbits, how satellites, revolve around one particular, planet or Earth, most probably. More precisely. And if we talk about ocean tides, so moon's gravitational pull also, creates a certain bulges in the ocean, and that causes high and low tides on Earth. Okay, in ocean. Now, space exploration, gravity is very, very essential to calculate that how much, like at what trajectory the spacecraft should be, and planning other missions, a lot of things. So basically all, satellite related or whatever is happening in NASA, ISRO, everybody is dealing with this gravitation. So if you aim to go, in such, organizations, you must know the basics of it. Okay, so in everyday life where we see, for example, if something is dropping like from our hands, okay, creates water flow in rivers, water flowing in, a downward direction or downhill direction, from hill to the bottom, okay, near the plains. So why that, waterfall is like that and not going upward? So all these things and rest a few more you can read here. And if you have any doubt, you can ask as well. So now coming to the question. So first is the gravitational force between two objects depends on mass, distance, or temperature. Now you can tell there can be multiple answers as well. Okay, so try answering that. Then the second question is, if the distance between the two bodies is doubled, right? I told you those two concepts you have to remember. So if distance is doubled, okay, then how much force will be there? Will it become half? Will it become 1/4? Will it become double? So you can recall it. Last answer is already given to you, but I want you to remember it. Okay. So the value of G is, that is gravitational constant, is 6.67 into 10 to the power minus 11 Newton meter square per kg square. Okay. So I hope you'll remember this and not forget. Thank you so much for joining the session. I hope you liked it. Okay, if you have any feedback, if you have any doubts, queries, questions, you can ask me in the comment section. See you soon. Take care. Bye-bye.